Good morning. Yeah. Let's discuss today technoeconomic synthesis of soda ash. So this is one of the important product used for it has a lot of application. So in today's session, we'd like to learn what is the basic process, then what are the different processes used for this. Next would be what are different reactions involved. Then we'll learn about the internal of process in terms of whether it's a reactor or it's a separation unit, and then about the economic consideration. So there are different methods of production of soda ash. So one is ammonia solvay or ammonia process. Before that is a Leblanc process. And the improvement of solvay is a dual solvay process. It's called a dual process. And or otherwise you can directly use what is available with nature. So let's look at the flow sheet. It's a little blurred. So any flow sheet you take, it has two parts. One is the main reactor, where you have raw material coming in and you get a product. Part 2 would be separation, which will get you a desired product. So you can look at the two processes which act as a reactor. One is the ammonation tower, and you can see this is a carbonating tower. This two is the main process, and then you just have ammonia recovery column to recover ammonia. So this is a solvay process. You just give, if you want to make 1 ton of soda ash, you require around 1.55 ton of salt. As you see for reaction, it is NaCl reacting with calcium carbonate giving you soda ash. But the problem with this process is you have calcium carbonate which has very less market value, which has a disposal problem. And in this you require 1.2 tons of limestone and then 0.09 ton of coal. And these are few figures in terms of the cooling of water requirement and electricity requirement, with considering capacity to be around 200 tons per day. So if you just refer to the flow sheet we saw, just remember there is ammonation tower, there is a carbonation tower, and then to get in CO2 we have lime kiln, and then you recover ammonia so that it can be used in process. So when you speak of ammonation tower, what you do, you add brine to it, okay, and brine is contacted with ammonia, and second tower, this initial reaction added with CO2 gives you ammonium bicarbonate, which is a main product. And after this, you decompose this ammonium bicarbonate to get sodium carbonate. So you can see, you can remove the impurities first, then dissolve ammonia, dissolve CO2. Now main is a carbonating tower which is around 22 meter high and 1.8 meter in diameter, made of cast iron. So in this it is operated in a very logical way, where you have two ends operating at a low temperature, whereas one end operating at 45 to 55 degrees centigrade. The reason being, a main reaction occurs at this particular temperature, is 45 to 55, to make ammonium bicarbonate. Now second, we want to solidify it so that it can be recovered from a remaining liquid stream. That's why two ends are operated at low temperature, which precipitate ammonium bicarbonate. You can look at the chemistry. You have, this is overall reaction, but then when you look into a nutshell, a sub reactions, you have NaCl reacting with CO2, ammonia, water to give ammonium sodium bicarbonate. Okay, this is the main process. Now you can either use ammonium chloride to recover ammonia and then reduce ammonia requirement. We'll be looking at the chemistry in the class, which would be actually a controlling step. The major equipment is a calcination equipment to maintain the two different temperatures in the same equipment. This gives you a basic idea of the soda ash problem, different uses of soda ash, and actual mechanism of how does the calcining term operate, that can be taken in class. Thank you.